So this is a PDP1170. This section here is the main CPU, where we have a control panel which we can use to view the current status of the machine while it's running. We can use the switches to start the machine, and we've got displays of the address and the data bits and see activity on the computer as it's running live. And in the side here, we have all the CPU boards. We have a DISC controller called a mass bus controller, and that runs a DEC RMO3, which we have here. This is a 67 megabyte disk drive and is connected to this computer through a thick control cable. The controller is able to support up to 4 of these drives. We currently have this one, which is fully working, fully tested, and we also have one which is nearly fully working as well. So soon we will have the capability of doing disk copies of the original scrapbook discs. Going back to the computer, this section here, this is a memory box. It's quite a big bit. It's the full size of that cabinet. It goes right to the back. And that provides 1 megabyte of memory, so 512 kilowords of memory. And we also have a second disk drive here, a DEC RLO2. This is 10 megabytes, and we use this to get operating systems onto the machine. We used it to also load diagnostics called XXDP. And then I've got a DEC VT320 terminal, which we use to start the computer and to start programs, run processes, and shut the machine down. And on the top of the computer here, we have, it could be described as modern. It's not really, it's probably from about 1995, something like that. But it shows that something that was at the end of the PDP11 family evolution, that it can still run on something that was built in 1976. Okay guys, so I'm going to show you the PDP1170 booting. What we do is we initially boot from this drive, and then we'll ultimately boot from the second drive. The reason being, the second drive has newer software on, but we don't have the firmware in the machine at the moment to properly boot that drive. So it's a 2-stage process. So what we'll start with first of all is we'll power on the PDP. We'll get nothing on the screen yet other than what's previously been on the screen. Not until we start these drives up and start the system booting off this operating system. So we'll start this drive first. Okay, so that drive's now come live. And what we do is we load a start address on the console to start the microcode that then boots this disk drive. So I'm halting the computer and I'm loading the address, which is 177730006. So each set of 3 is a code from 0 to 7. PDP is working octal. So now I'm going to load the address and start. Now the computer should start to boot. We'll see the light flickering on the front of the drive, and we'll see that we'll get a banner at the moment for the operating system that's installed on that disk. And there we go. So that's now booted an operating system called Rustus. This has got Rustus 9.6. Quite well, everything here is an old operating system, but that's quite old. It doesn't have year 2000 support. So what I'll do first of all is put the date and time in. Um, 6th of February 1999, and the current time, which is 15:25. Okay, so now what I'm going to do is start this drive up, this second disk drive. Okay, so now I'm going to start the computer off this drive. And we can hear the disk heads seeking within the disk pack to read data to be able to start the computer. Okay, so now the next thing we're going to do is change the date, because obviously we had the incorrect date before. So I'm going to change the date to 06-FEB-22 and leave the time as it is. The next thing I'm going to do now is start the computer. So when it boots off the disk, it's in a single user mode, and the PDP is able to support many simultaneous sessions on terminals such as this. So this is now starting the computer to what's called time sharing. Allows it to be in a multi-user, allows us to use to run multiple jobs on there, such as tests or whatever the business applications are. Okay, so the computer's now started. So I'm going to log into the computer. And we get a dollar prompt which shows that everything's up and running. So for instance, I can now run a test to test the disk drive, which you'll be able to hear on camera. So now we have the computer running, it's able to run multiple jobs at the same time. Nothing's running at the moment. If I draw your attention to the front of the computer, you can see the data lights is going round and round just in a pattern. That shows that everything's running, but the computer's idle. It's not really got anything to do at the moment. So I'm going to start a few jobs running. You'll hear the disk drive getting busy, and you'll also see the lights change. So I'm going to run the test. I'm going to tell it to run forever. And what we're going to do is we're going to tell the job to run in the background. It's going to detach, which means now the job's running. But now I can log in again as another user, or the same user in a different session. Next thing I'll do, I'll run a CPU exerciser. And what you'll see is the lights will change on the front of the computer. So now the lights changed on the front. They're much more, they look more static, but they have bursts where it's idle, but then they'll have bursts where it's very busy as well. And the next thing I'll run is a monitor job that allows us to see what's going on the computer. So that now allows us to see what jobs have been set running, what the state are, what's actually happening with the job, shows you your disks, how many errors have occurred, and so on. So it's quite a nice single view to see what's happening on the computer at any one time and what the loads are. My name's Sean Allison. I got involved with the museum about 5 years ago, and it all came from the fact that I used to maintain a lot of the equipment that's now in the museum, and it was probably just trying to relive some of those old times and provide the support to the museum to start getting some of these pieces of kit back operational again after all these years.
My name's Allison. I'm 65, retired now. Sean is my brother, and he originally got involved and invited me to come on board.
I've got a history in computers, and that's how I knew Ray, because I used to work with him at Systime. And a few years ago now, Ray rang me up and said he had a problem with a particular drive, an RL02. And I said, oh, this is the fix, and he did fix it. And he said, well, do you want to come down and help us? And that's why I thought I'd come down and see what it is, because all the kit that we're repairing now, I used to fix back in the 80s.
I worked with Malcolm and Ray at ICM computer group for many years, working in the workshop environment, bench engineering.
The PDP11 is one of the DEC, or Digital Equipment Corporation, computers that was probably the most successful over the years. It was introduced in 1970 and was built to around about 1991. The computer that we've got was built in around 1976 and was at the time the most powerful PDP that had been produced to date, of the most powerful PDP11.
They had 18-bit machines, 22-bit machines, 16-bit machines. As the machines grew and developed, the power obviously increased. Capacity of storage attached to the machines increased. So the PDP11 is an architecture based on Unibus predominantly. So you have the central processing system, but it always interconnects to a Unibus, which is where all the peripheral devices, disk tapes, controllers, printers, terminal devices are all connected into.
We used to work professionally on those systems, mainly in the field. So, you know, we had various customers, different industries, retail, medical, steelworks, etc.
This machine came from the National Physical Laboratory. It was a system called Scrapbook, and Scrapbook was a predecessor to the World Wide Web. So Tim Berners-Lee invented the World Wide Web, but this computer was running similar technologies to what became the World Wide Web several years before.
The technology is TTL logic, transistor logic, 7.4 series chips basically, is what it's made up out of. There were no microprocessors then, so it's all in discrete logic, which is very repairable. You know, makes it good fun for us to diagnose the problems we've had. You can go down to chip level.
The very first PDP1170 had core memory, is the same technology as the Argus. Very, very heavy and very complicated to make. This machine has the later, it's called MK11 memory in it, which is solid state based on TTL technology, and it is capable of running up to 4 megabytes. This current system has 1 megabyte installed.
The 67 megabyte large disk storage packs that we're currently working on the 1170 in the environment in the workshop next door, they are 67 meg, which is quite a small size capacity, but at the time it was quite large for its day. And you'd have maybe 4, maybe 5, maybe 6 of those drives connected to the mass bus controllers for the 1170. So you could actually have quite a large amount of storage, but you'd need a large number of drives to do that. And of course, with them being removable drives, you can move data around and take backups, etc.
One of the worst challenges we had was today, actually, not too long ago. We were building an RMO3 storage drive, and everything was going fine. Then we suddenly had a head crash, much to our dismay. There's the 5 platter discs. The top and the bottom are sort of protection platters, and the 3 inside are where the data's written. The pack spins at 3600 RPM, and when it's up to that speed, the heads come out on the voice call and sit over the track. In comparison, the track distance from the actual platter is equivalent of a jumbo jet flying 1 inch above the ground. Very slow, and occasionally, if you get dust particles in, it sort of makes the airflow around the head wrong, and it just bounces down and hits the platter surface, and that's called a head crash. And it's as far as the disc is going, it's wasted disc now. Got to throw it away. No use.
The intermittent problems are the worst ones, because when you start troubleshooting with the meter, oscilloscope, etc., the fault can go away. And so we've got through them with process of cleaning edge connectors and pins, etc. So very often it's caused by corrosion on the edge connectors of the boards. There was one particular one which was a hard-on fault, which meant it didn't go away. Took a lot of finding. We had to go right down to component level and to put the oscilloscope on the back plane, etc., following signals, and we found a signal from one board in the memory management unit not appearing on another module in an adjacent slot. And we couldn't see anything, but we compared a good backplane with our one that had got the fault, and we found some continuity on the good one that wasn't there on the bad one. But no amount of checking the wires on the back revealed the problem. And then with a really strong light, we had a look in the slots, and there's a piece of insulation tape was jammed in where the slot plugs in, hardly visible. So yeah, that was good to find that. When we were younger, it was easier. You know, with 65-year-old eyes, etc. Now it's so much harder, and so you need good optics and a strong, strong lens and a good light.
Spare parts is a bit of a challenge. We do have a spare PDP1170 within the museum that we've used to take parts from to get this one up and running. That's the only source of parts that you have, really. You have to, unfortunately, use other old vintage systems to be able to rebuild one.
Spare availability is non-existent, really. Even the components, which are chips, it's not like today's where everything's stored in one chip. You have to find a board that you don't want and take the chip off that, and that's the only way you can fix things. Reading circuit diagrams, they themselves sort of prove difficult to find, but once you find them, you enjoy it. It's really good fun. I'm enjoying every minute of it, put it like that.
We live obviously in Yorkshire, so we don't come down that often. We come down every few months. But we're getting close now to being able to finally mount the original scrapbook disc packs, which have been in storage since we started. We wanted to get a machine that was stable and that we had full confidence in, and we now have that. So we are probably within the next year, I think we might have the project completed. The machine's up and it's running, it's going to go on display. It would be great for guys to come and have a look at it and see it in operation, and maybe get involved in the museum more like we have. It's great fun and it's very rewarding.